Good morning, folks. We are back with Paul DeBolt at DeBolt Machine. I always enjoy coming over saying hi to Paul. The goal today is to talk about machining thin parts.
So what I'm going to do here is demonstrate the fact that we can clamp it, we can machine it, and where we're machining it, we probably can't even see where it's distorted because this is not flat anyway. This particular setup really helps you if you're just doing a few pieces. You can expand on it. This can be done on a CNC machine as well. If you machine thin parts like this, you know they're not particularly flat, similar to the way aluminum. If you machine a lot of aluminum, you know that it's got waves in it. So that affects how you hold things. What your problem is how much clamping pressure that you put on any given item and how flat it is before you start putting that clamping pressure on it. If I distort this by putting clamps on it, and when I release it, it springs back to the original shape. Now it's out of tolerance or out of square, or good grief, it's a piece of junk. The machining process itself causes distortions. Let's say it distorts 5 thousandths. Okay, we're going to leave 10 thousandths on it from finished size. Then we release the clamping to take out that distortion, so when you remachine the surfaces again, when you release the clamps completely, you don't have that distortion. Or if you do, it's so small you can't really see it. The trick is, when you do your remachine, how much do you release? Because if you release too much, bing, it's out of the machine. If you don't release enough, you still got distortion. If you study this, what will happen is the more lightly you clamp it, the more accurate the part gets. Okay, well, more risk throwing apart too. Obviously, if I clamp it where my fingers are, it's going to bend like a pretzel. You know, so I want to clamp it here, because if I clamp it here, that's where I'm going to get the least amount of stress, provided it's perfectly flat. What I've got is a billet clamped in here that's turned, and you'll notice that I have the counterbore cut in here, so it's only going to touch here. The same thing with this cap. You want to machine this in the lathe to make sure this is square. That way you don't have this like this in here. You want it true as you can get it. The only thing we're going to clamp with is this. Now I can line this up. If you cut this diameter, the diameter you want to end up at, or slightly under it, okay? So I want to get it in here evenly.
And you're just using experience to feel the comfort of the tailstock pressure.
Yes, I have this back against here so it can't back up. If you have it in a CNC machine, I think you'd want the same scenario. If you got it in hard jaws, it'll probably be okay. But and I think you want to clamp it like this, because if you hold everything out on the first couple of teeth, it's hard on the chuck. Why strain a chuck when you don't have to? That way this can't move. You could almost put any amount of pressure. Now you could back the pressure off some if you're worried about distortion for some reason. But you see, once I turn this, and of course that's sticking out there ways, so you don't want to take the huge cuts off of there. If you turn it round like this and make it into a disc, you could take a fixture over here and mill a round hole to drop it into and start clamping, and do whatever you need to do to the center, whether it's mill it out or drill holes in it or whatever, or put spokes in it for a wheel or like a clock gear or something like that. You could do that stuff to it because you have a starting diameter to line everything up on. Now you can clamp it into vise, you can mill vise jaws, but you know about that warpage. That's going to cause your warpage problem. Now where you run into a problem, if you're cutting steel or aluminum or whatever, you have to be careful how fast you can cut it, depending on how much center pressure you're putting on it, just like you alluded to. You don't want anything moving. If you cut it too hard, it'll spin it, because you're relying strictly on friction here.
Did you just happen to have that insert in the lathe, or was that specifically one that you grabbed?
Yeah, we'll see that. That's a positive.
So you want positive rake to minimize the cutting pressure.
That's right.
Cutting forces there.
Yeah.
Boy, that looks neutral, or even slightly negative, Paul. That's crazy. Yeah. But that does have that positive shear.
That's right. Yeah, it's a Sandvik.
Okay, okay. Positive rake inserts tend to leave a better surface finish, and they have a lower cutting pressure, so you can cut faster or with less horsepower per cut. The downsides are that usually they don't last as long because they're weaker. They have kind of exposed wave tip to them. And the second is that they usually couldn't be double-sided. So your carbide insert might only have 2 or 4 edges, whereas the negative version of that same style tool, you could flip it over and get double the cutting edges, which really does matter. It forms a very natural shearing action with that tip like that.
I mean, if you had negative tools in there, you go, well, I don't want to buy a positive. You could do it.
Okay.
You just got to be key. You're going to be cutting slower.
We do really like super glue, and we like vacuum as well too. We just don't use it a ton. But the one piece of advice I often end up talking with folks about is when you're doing stuff like that, if you've got a facing operation, and let's say it's a 6x6 plate in the mill or even bigger, put away that 2-inch face mill. Mm-hmm. I'd much rather start off with a 3/8 inch tool or 1/2 inch tool and take smaller step overs. It's a CNC. You can walk away and go do something else because the smaller diameter puts a lot less tool pressure on it and less likely of throwing that part.
Yeah. Over here, I set something up. This is a fixture for a control panel. If you look at this control panel initially, you think, well, we're going to water cut that. Well, not if you're going to engrave it, you're not.
Okay.
Now, if you did it with a water cutter, you'd have to do it with a water cutter and cut. You could cut this window and some of the windows and holes in here, but you wouldn't have the script on there. Now you got to line it up. This way, I don't have to line anything up. It's in the program. It's lined up. Everything's synchronized.
Yep. Mine aluminum extrusion of that aspect ratio, that thin and that wide, it is a potato chip. I mean, it is curved, bowed, twisted.
When I mount it on a machine, there's 2 square blocks that lay in here, and these bolt to those.
Okay.
When I clamp the sheet down on top of here, I put the clamp here and a clamp here. Then I go around and drill these holes. And these holes here are the holes that mount this on the cabinet that this thing goes on. So then I have a program stop. Put this clamp on and put this clamp on. Then I remove these clamps, put these clamps on here. So now I can machine the outside of the panel, and I can machine all the features in the panel and put all the wording on there and everything.
All access to it. Okay. Yeah.
And in essence, it's not exactly one operation, but it's not really two operations.
Yeah, right. It's like an op zero where you got to poke a couple holes through it.
Yeah, that's right. Okay. So then once I get that done, I take these off. This is still bolted to the table. Take the panel off, put another panel on, and start the process.
So you never lose your datum.
That's right. You never lose your datum. You got all your script and all your pockets and everything machined in one operation.
That's slick. Yep.
Now you can set this up, and I've seen them set up like this, where you got it on a pilot changer. I have to take the clamps off of here and put these on here. Well, you could have it switch out, switch the clamps around while it's running one.
Next one.
And then put this back together and run the second half of the program when the other one comes out and do the same. Just keep switching things around. Of course, you got to pay attention.
Yeah. I'm assuming that this whole window is cut away on the part. Do you just slot it out and have that piece of metal flopping around, or you can machine the whole thing away?
I'm lazy. I don't want to stand here and go, is it going to crash?
Is
it going to tear the end mill up? No, I'm just going to cut it out.
Cut it all the way. Yep.
Yeah.
Does it shatter, given it's that, because effectively it's not supported anywhere in the middle, so do you have...
Well, it can be. You notice there's some holes here.
Okay.
When I put these holes in here, I can take and put 1 or 2 holes in here to stabilize it. And when you talk about stabilizing it here, you'll notice that I don't just put screws in here and tighten it down. I have...
the whole bar.
To try to spread the clamping pressure as far as it'll go. And of course, in this case, you want to go as far as you can go and keep it out of the way of what you want to do. But I want to crowd it and get as much done as I can without changing anything. In this trade, it's all about the dirty little details. And if you don't pay attention to those details, you just end up with crap. And this is particularly important when you're talking about cutting machine parts that are thin, or you're trying to avoid distortion. And it's amazing, and it amazes me even today how large a piece you can get with distortion in it. And you think, wow, that's so thick and it's still distorted. And you say, well, I'm just cranking on it with a wrench and I distorted it, and look how thick that is. Well, if you've got the measuring tools, there's some things you can measure that you don't realize you can measure. And
over the last 6 months, we've been building fixtures for our tombstone on our horizontal. We've been putting indicators on fixtures that are all the way up against cast iron. And let me tell you, even one of those Mighty Bite Uniforce clamps that opens up, that causes that whole fixture to bow out. Now I'm only talking a thou or two, but I care about that.
Oh,
and you at least need to know it's going to do that.
Yeah. I hate these things, and they're widely sold. I mean, they're everywhere because they're heat treated.
Okay.
For that reason, and they get dings in the bottom of that, and when you put that on your Bridgeport mill, and I'm talking about a simple Bridgeport mill, it damages the table.
Got it. Never thought about stoning the bottom of those.
Yeah, you know, you've got
pads.
and the worst part of it is people get these things all over the place like that, and they get the clamp on an angle. Now you have to say, well, I need to clamp to angle so I know the pressure is predominant part of the pressure is on the part.
Yep.
Yes.
This is textbook wrong. You need the stud to be close. Assuming this is what you're clamping, right?
Yeah.
You want to move everything kind of back.
Yeah, you want the stud to be closer, but that's not the only problem that you can have here. If I angle this clamp, and I'm going to make this extreme like this, what it does is it wants to pull the part this way and distort the part, okay? And you don't want extreme angles. Well, how extreme can you be? You can take a level like this and put it on here, and people say, well, gee, that's a lot of work to level that thing up. But how important is the squareness or the distortion in the part? You can put it in there and get it reasonably level or almost level. If you've got the bubble in between the lines, it's probably good enough.
Yeah.
Okay, well now we'll talk about this. When you put this on here and you have your stud in the machine and you've got this clamp at an angle, it's pulling on the stud like this.
Yeah, right.
Well, what's that doing? How's that holding in your T-slot? It ends up holding on this angle right here, right on this edge right here, and it ends up putting a lot of stress pulling one angle or another. What you can do if you can't get these particularly level or you want to stabilize the holding process in your machine, you buy nuts and washers like that.
Oh, whoa. Look at that. Will you show that? Hold that up? That's cool. It's got a concave and a convex surface, and they dish together. That's
so
slick.
What happens when you put this on here instead of this tradition? You know, this, a lot of people are familiar with that, surely. When you put this up here, and this is at a slight angle, you get a straight pull on it. And this way, you're not pulling your part and adding distortion that you don't want.
A lot of times I see the strap clamps that are kind of just, they come to a slight taper and a point, but it's still a flat plane bottom. This one has a slight radius.
Yeah, see, that has an arc on there.
Yeah, so that way, because you're going to be at an angle, you're not having it contact the wrong.
Then that gives you that flexibility a little bit here. And I do this all the time when stuff that you're wanting to be gentle with. You take copper, you should have a strip of copper 1/2 inch wide, 1/8 inch thick, that you cut pieces off of like that. Whether you're using it in a 4-jaw chuck on the lathe or you're using it here like this. Typically, if you're clamping aluminum, for example, this is not going to be soft enough. You're going to need nylon or something like that to put between there so it doesn't bruise it up. I have a hole in the center here. So then I have the clamps here, the initial clamps, made out of nylon, of course.
Okay.
So right in here, you see there's a relief underneath there. So it's only clamping over top of here where there's metal underneath, so we don't want to have any distortion.
Yeah.
The nice thing about it here is when you take your raw material, if you have this machined around to whatever the finished size is, when you throw the material up there, you can get it centered up by eyeball.
Just feel and finger,
Yeah. You can set it up this way and machine this completely finished and put chamfers on it and do everything you want to do with it, which I didn't do. There's no chamfer on here. I just got chamfers on the holes.
Okay.
There's no chamfer cut around here, but you can also take a lollipop cutter or one of those bevel cutters and go around and cut the bottom side.
Shameless plug to our video dedicated on all the back chamfering tips and tricks. It is great for a one-op flow.
This allows you to machine all those features without having to move anything.
Yeah.
I'll fire this monster up.
While Paul's getting the machine turned on, the other kind of businessy tip around this stuff is when you think about buying material for a job like this, a lot of times the way we've found that vendors will quote stuff, and that could be your material supplier or a grinding supplier or something, is kind of by the piece. So on parts like this, if you, instead of buying 400 individual pieces, buy 100 4-inch strips or something, 40 10-inch strips, because you'll often find, at least get it quoted that way, that they kind of look at that double disc grinding fee or Blanchard fee buy the part or the saw cutting, and you can, as long as you can make the fixture work to cut 4 at a time out of one strip, really a win all around. I still think it's awesome. You probably have one of the only 3-axis Heidenhain CNC machines in the state of Ohio. I'm serious.
Yeah.
Oh, so it does have to home.
Yeah.
That's one of the interesting things about that Okuma we've got is it has absolute encoders. It doesn't ever have to home.
Well, they seem to be getting away from that or doing it at all anymore. If you're wanting some sleazy way to check this for flat.
I like how you're getting a little more sultry as you age, Paul. Get a little more fresh, a little more grumpy. I like it.
If you took this part and you say, I want it to be perfectly flat, you deck this off in the machine, you emery it down, and I'm just talking about for a few parts. If you want it really good, you're going to have to buy the material, so you don't have to do that.
Yeah, have a double disc ground or something. When you sand that, not only do you learn a lot about whether it's concave or convex, but sometimes there's a burr from the extrusion process, shipping, handling, a saw cut, and that burr can...
Yeah, and you can overcome some of that if you get on your supplier and say, hey, guys, don't throw this thing around like it's a rag doll. Let's get it here in good shape, and then they'll put it in a box instead of a tube. Or
when we built our Lex ERP system, we have our POs to our suppliers clarify that it has to be stacked in a box on a pallet jack compatible pallet, and every one of those words came from hard lessons learned.
I already got the program loaded, so it'll put the holes in there for the screws.
Pretty fast machine.
Yeah.
I remember you saying you wanted this machine because it was the Heidenhain control. How did you teach yourself, or how did you learn? Don't tell me you read a book.
Yeah, I'm pretty sure.
Really?
Well, I've been around machines an awful long time. I mean, George gives me a hard time about that all the time because we have FANUC controls in here, and we have the other control over there on the lathe. If I had my druthers, I'd have all the same control.
That last stop was a chamfer?
Yeah.
Okay.
So now it's stopped.
Yeah.
And you can see that it's in the middle of the program there. If you look at one of these closely, you can see right here where it's got scratches. So we made these little pads, okay, and they started out as a rectangular piece, and it just got machined in the process, which you can do that. And then you'll notice I make sure that I put all these clamps and stuff in place before I take these loose. That way we have everything machined on the outside to your hole pattern.
We'll add this video onto a page on our NYC CNC site that talks about some of the more precarious fixturing methods, including vacuum chucks and super glue. But one of the awesome key things, and Paul mentioned it earlier, is sometimes having 2 really light duty clamping things is all you need. So if you have a part of a known dimension, you machine a mold or an insert that goes around the part where you can clamp the heck out of that mold, if you will, or that jig, and then you might just need one tiny 1032 screw. A single screw would keep it down, and then that fixture that you have around it holds it, much like you would block in a small thin part on the surface grinder.
Yeah, you know, and you take these clamps loose. And of course these are, you know, if you look at these and you know anything about plastic, these are thin.
Yeah.
We didn't have to put a lot of clamping pressure on here to hold it down, just put the holes in. And mainly because we don't have any twist on here to amount to anything because of, you know, how milling wants to, you can hold stuff drilling easier than you can milling. So you want to do the drilling first. Now you could machine the top of this and have 2 clamps over here and machine it so you can get the plane on the top perfectly flat.
Yeah.
Okay. You can move, typically before, if you don't have a vacuum table, you might clamp it in a couple spots if you don't have any holes in here and machine the partial profile, then put clamps in another position, change the other profile, but then it becomes important on how you're clamping, where you're clamping, how much pressure you're putting, how hard you're pushing on it, because you don't want to warp it.
Yeah, but you will warp it, you just want to minimize.
Yeah. And you established that you need a lot of torque tools.
Yeah.
And this is important if you're relying on your own talent and you know how tight you're tightening. There's limits to that, but if you have personnel working for you and you want the torque the same on everything, it's torque wrench buying time.
Yep.
You can't do it without that. And that's why automated clamping is so nice, where you can adjust the air or hydraulic clamping. That's one reason I like the end shoe design, because you can build that. We've got some pictures that you can put on that table.
That's cool.
And you can control the clamping pressure so nicely.
Yeah.
And it's consistent.
Yeah.
You turn it on, turn it off. Turn it on, you turn the pressure wherever you want it, and you don't crush the parts. And it doesn't matter who's running it, it's going to come out the same.
We saw this tool at Area 419 that's an Ingersoll Rand digital torque system, and it's pretty cool, but it's about 20 grand, and it has a computer on it, and you can program a fixture, and it will unload, and then it'll count when you reload, and it'll say, nope, I need to see 10 screws, each one torqued, and it knows 25 foot-pounds, it automatically adjusts, and if you don't do 10 different screws, it knows, and it kind of alarms out, but it's 20 grand.
Yeah. And that's it.
That's it? There we go.
Get a lollipop cutter or any of the fancy little cutters. This is a small part to be doing that with. But you can put undercuts in here, but you have to be careful when you clamp here to do your first operation. The clamps overlap in here far enough that you're clamping on a solid area.
Yeah.
But you can go around here and cut chamfers on everything and have a completed part, completely burred, the whole 9 yards. The only thing you're not going to burr is the holes in the back.
Yeah, right.
And you can do that by hand, or you can set up another setup. If you machine an island to just fit that, and you put this around this way, and you put clamps here, you're still clamping here where it's thick.
Yeah, right.
Whereas you're clamping it with a vise, you better have some kind of pressure control, because you can't get the pressure just right without warping it. Now this is a little stiffer than a lot of things would be, because it's got a big radius in here, and if you clamped it this way, you could probably get away with it. But it depends on what you're doing here and how close the tolerances are on it. This is just one thing you can put in the back of your mind when you're going to do something thin. And some things that applies to really well, and like I say, if you get something that you have to machine the outside of and you don't have any holes in it, you're going to have to machine part of it, and then the other part, well, then you might go to the tape or the glue, or I think that's a better alternative than vacuum, because that can be expensive. That kind of gets around that. Now, I don't know how flat you get that relative to if you're trying to get the thickness of the floor in here between that and the outside wall to a certain dimension. If that plays in this, if you're decking that off and then you're bolting that down there, as long as you don't get any chips in there, it's going to be really flat.
But to your point, if you got a large vacuum chuck and you're taking it on off the machine, you need to check it or potentially redeck it at some point, and you got some time and money in those vacuum chucks. Well, as always, folks, I appreciate Paul's time. It's a pleasure to see you be over here again.
Yeah, sure.
Take care, folks. See you soon.